Okay, let's dive right into this explainer. Today, we're unpacking some truly mind-bending new data that suggests the universe might not just end, but actually fundamentally restart. For a long time, we thought we had the ultimate fate of the cosmos totally figured out. But recent scientific discoveries, they're turning everything we know completely upside down. We are going to look at the life, the death, and the absolute wild potential rebirth of literally everything that exists. So, to kick things off, I want you to consider this massive existential idea straight from our source material. What if this isn't your first time absorbing this exact information? If the universe operates in this infinite loop of expansion and contraction, you might have lived this exact moment sitting right where you are billions of times before. Keep that crazy thought in the back of your mind as we walk through the mechanics of how this could actually be possible. Section 1. The Shrinking Universe. Let's explore exactly why scientists are suddenly talking about a contracting cosmos and how we arrived at this incredible realization. For decades, we kind of just assumed our depressing destiny was the big freeze, right? In that scenario, the universe just expands forever. Stars burn out, galaxies fade, and eventually even supermassive black holes evaporate into this cold, dark canvas of absolute nothingness. But brand new findings suggest the exact opposite. We're talking about a terrifyingly hot collapse known as the Big Crunch, where the universe shrinks all the way down into a single, violently hot point.
Section 2. Rethinking the Big Freeze.
Now, to deeply understand this major plot twist, we have to rewind slightly to the exact moment humanity figured out the universe was actually expanding in the first place. Back in 1929, the astronomer Hubble, the guy they named the famous space telescope after, along with Humason, made this monumental discovery. By measuring the light spectrums of spiral galaxies, they saw that galaxies were redshifting, meaning the light from those galaxies was stretching into longer, redder wavelengths. This was the ultimate smoking gun proof that the fabric of space itself was stretching outward, and all these distant galaxies were moving away from us. And honestly, the best way to picture redshift is to think of the Doppler effect. Think about a police siren changing pitch as the car drives rapidly away from you. The actual literal note of the siren hasn't changed at the source, but the frequency hitting your ears drops because the vehicle is moving away. Well, light works in exactly the same way across the cosmos. Hubble essentially discovered that almost all galaxies are like sirens speeding away from us. Section 3. The Dark Energy Anomaly. So naturally, we assumed that the immense gravity of all those stars and galaxies would eventually put the brakes on this cosmic expansion. But in the late 1990s, looking at distant supernovae revealed a massive anomaly. The expansion wasn't slowing down at all. It was actually speeding up. There is this mysterious, repelling force driving things apart, literally pushing against gravity. Scientists dubbed this, they called it dark energy. The crazy thing is, nobody really knows what it is. It's just a placeholder phrase. But we do know it makes up nearly 70% of our entire universe. And for about 25 years, scientists considered this force an absolute unchanging constant. Fast forward to 2025. The Dark Energy Spectroscopic Instrument, or DESI for short, started giving us real answers about this mysterious force. And the sheer scale of this project is just staggering. It's a 5-year collaboration out of Kitt Peak National Observatory in Arizona involving over 900 researchers. They're using a telescope that captures light from 5,000 galaxies simultaneously, all to track dark energy's effects over the last 11 billion years of cosmic history. To put that intimidating astrophysics into perspective, the very first data dump from this project takes up 270 terabytes. That is an absolute mountain of data tracking 4 million stars and 13 million galaxies. That completely dwarfs the capacity of even the most advanced commercial computers you or I could buy. And as scientists poured through it all, they realized something that totally shook the foundation of modern cosmology. Dark energy might not be constant. It might actually be evolving and, most importantly, weakening. Section 4. Gravity takes control. Because you see, this is exactly where the fate of our universe hinges. If dark energy is like a carton of milk with a shelf life, and it eventually stops pushing, our old reliable friend gravity never gets weaker. It's going to start pulling. A research team at Cornell ran the numbers based on this new data. If dark energy changes from a positive pushing force to a negative value, they established a truly shocking timeline. Right now, the universe is 13.8 billion years old. According to this new model, the universe will hit its absolute maximum, peak size, in just about 7 billion years. After that, the long retraction begins, leading to a total implosion in roughly 20 billion years. Now, the very first sign of this impending doom wouldn't actually be some massive cinematic explosion. Instead, distant galaxies that have been drifting outward for tens of billions of years would just pause. And then that cosmic redshift we talked about earlier, it would reverse. It would become blue shift. The light wavelengths shift back to shorter, blue frequencies, signaling that the expansion has reversed and the entire cosmos is slowly moving inward toward us.
Section 5. The Big Crunch.
And right here is where the narrative shifts dramatically. The cold, melancholic, slow fate of the Big Freeze is violently replaced by catastrophic heat. Over billions of years, gravity relentlessly pulls the fabric of space tighter. First, massive galactic clusters and superstructures are drawn back together. Then, space gets so ridiculously tight that entire galaxies merge. And eventually, individual stars begin to catastrophically collide. As space condenses, the cosmic microwave's background radiation, which is normally just a hair above absolute zero, has nowhere to go. It skyrockets to thousands of degrees. It essentially boils empty space itself. And finally, all matter collapses inward. In those final hundreds of thousands of years, it's basically a reversed Big Bang. The structures we know, planets, moons, red giants, pulsars, they're all stripped down to their raw elements. The very nuclei of atoms are literally ripped apart. The entire cosmos turns into this swirling, superheated bubble of plasma, black hole singularities, and immensely hot interstellar dust. And then, in mere fractions of a second, this great deflation reaches its climax. Absolutely everything in existence is crushed into a single, infinitely dense point known as the singularity. Inside this point, all matter, all energy, and the very laws of physics themselves just break down entirely. If the story ends there, that's it. That is the definitive Big Crunch. We existed, and then we were crushed back into nothing.
Section 6. The Endless Cosmic Loop.
But what if that isn't the end of the story? Consider what might happen immediately after that apocalyptic cosmic collapse. Instead of just remaining a compressed dot forever, that massive singularity could trigger a big bounce. This would function exactly like a second Big Bang. In fractions of a yoctosecond, which is 1/septillionth of a second, by the way, quarks would be forged. Matter and energy would violently stretch outward at temperatures of trillions of degrees, expanding 1 billion kilometers in less than a nanosecond. Neutrons, protons, and atoms would form all over again. What's really fascinating here is that this idea of eternal, cyclical universes is incredibly old. I mean, it even appears in the ancient Egyptian Book of the Dead. But it wasn't until the 1980s that modern bounce theory was actually coined. And today, cosmologists aren't just philosophizing anymore. They're using the DESI data, which provides the very first real mathematical mechanism for a collapse, alongside upcoming tools like NASA's Nancy Grace Roman telescope, to actively hunt for the mathematical ghosts of past universes hidden in cosmic radiation. Which brings us right back to that original, wild existential hook at the beginning of this explainer. Think about it. If this universe collapses and explodes in a loop, if it's just a circle forever, then time itself is not a straight line from start to finish. It implies that the past could be full of infinite contractions and explosions, producing an infinite number of universes just like ours. As our source material brilliantly points out, if time is infinite and every possibility can be explored, well then every possibility can be re-explored infinite times. That means in an eternal loop, every single moment has already happened. You, sitting right there, absorbing the information in this very explainer, is an event that has happened 1 billion times before in past universes, and will absolutely happen again in the next. It's an immense concept to wrap your head around, isn't it? But the data suggests it's a highly plausible reality. So I'm going to leave you with this final thought. Knowing that our universe might be just one iteration in an endless cycle, if you had the chance, would you want to explore the universe that existed right before our Big Bang?